So today it's more about combinations, and I know you know that a combination, the order does not matter. What's the kind where it does matter? Permutation, good. If I said 4C2, I know that you know how to do that with factorials, but let's just remind you. Something factorial on the top, 4 factorial, over, well, do the rest of it. Just go ahead and do it. Take a second, use your calculator to do it. But there's a faster way I'm going to show you to do these combinations. But the first thing you'd want to do is make some stuff cancel. I mean, 4 factorial over 4 minus 2, which is 2, of course, factorial. And in case you forgot, on the C problem, there's an extra one of those. So simplify that all the way down, and you'll have an answer. It's just 12 divided by 2, it's 6. Raise your hand if you had 6. Okay, awesome. Now, that wasn't that bad. You could have done that one without too much pain. But there's some of these where they end up being such huge numbers that it's a real pain in the butt. So, for instance, 29C5. Nobody in here is going to want to have to do that in their head. So let me show you how to put that into a calculator directly. I don't mean 29 factorial over 24 factorial, blah, blah, blah. There's a way to just put that in. It looks like this if you're doing it right. It'll be something C something, and I'm going to show you where that lives. So I think the easiest way is to hit the math button. So everybody, we're going to just explore 29C5 because we want to do one that's actually hard enough to do in your head that you'd want to use the calculator. So how are you going to get that up on your screen? Here's what you do. You hit the math button. Arrow over, this is the arrow keys, until you see a PROB. That stands for probability. Then you arrow down until you see NCR. Now, there's two kinds of kids right now. The kids that hit NCR and then it pops up like this, box, C box, and that's super easy. You're just going to put a 29 here and a 5 here. But there's other poor kids that don't get the little boxes because you have an old version of the software. If you have the old version of the software, your calculator just says that. And what you need to do is put a 29 in front of it and a 5 after it, and then hit equals. You'll get the same answer. So whichever way you do it on the calculator, and don't do it the old way I've showed you. I want to see if you understand how to put it in properly, the new way. Now, if you don't get it, please just ask the kid next to you, because I'm going to walk around and I'm going to ask to see your calculator, not the answer. I want to see your calculator screen that says one of these two ways. And if you don't know how to do that, it'd be great if you could get that fixed by asking a kid next to you, so that when I get there, it's working. Otherwise, I will show you, but I don't have time to show all of you. I'm going to pause while I walk around and make sure you have learned how to put that in. Okay, I am now confident that everybody can do this. Yay. Because the hardest kind for today look like this. You have 3 of them on the top, all multiplied together, and then you divide by 1 on the bottom. All right, let me explain how this actually could work. So let's say, please set this up, write this out for me, and then here we're going to put FR for freshmen, SOPH for sophomores, and J for juniors. I don't have any seniors in this class, but I teach a whole bunch of kids honors higher algebra, and I have freshmen, sophomores, and juniors, all that take this class. Okay? Let's say that in this hour, I'm counting quickly, and I'm seeing, it looks like 33 of you. So we're just going to save the time and say there's 33 of you total. That goes on the bottom because that's where your totals go. It's what it's out of. So copy that down. You got a 33 on the left side of the C. Now, if I were to randomly pick 2 of you, I just put a 2 there because I just said we were going to pick 2 of you. What's the probability that it would be 1 freshman and 1 sophomore? There's the hardest kind of problem on the test. I got to teach you that today. So if there was 33 kids total and 2 of them are going to get picked out of the group, out of you guys, I'm going to pick 2. What's the probability I'll get 1 freshman and 1 sophomore? Well, I got to tell you how many freshmen and sophomores there are. So let's say that there's 25 freshmen in here, 5 sophomores. Would you be able to tell how many juniors there are? Yeah, you can do math. You can figure that out. How many juniors must there be? 3. Okay. And if I want, remember what you want goes on the top? Does that ring a bell? If I want it to be 1 freshman and 1 sophomore, 1, then how many juniors am I going to get? 0. Now, that is a pretty gruesome, complicated setup, but I want to make sure you make sense to you. 25 plus 5 plus 3 makes a total of 33. See how that adds up to that? And of the people I'm picking, 1 plus 1 plus 0 makes 2. And then, do you get that your handy-dandy calculator could do this part for you, and this part for you, and this part for you? But let's talk about some of them. How many ways are there to choose 0 people? There's only one way to do that. Now, I know it feels like 0, but it's not. It's 1. Because if it was a 0, you'd multiply the whole top, it becomes 0, and that wouldn't make any sense. So it's 1 for that. How many ways are there to take 5 sophomores and choose 1 of them at that time? 5. See how you don't need a calculator for either of those 2? Probably this one's going to be the same then. What's 25C1? 25. Didn't need a calculator for that either. But I guarantee you're going to want a calculator for that. Okay, you could do it yourself. You can. You could do it the old way. I'm happy you know this because once you teach a kid the calculator way, they typically don't want to go back to the formula way, but the formula way would totally work. 33 factorial over 33 minus 2, which is 31 factorial, over an extra one of these, 2 factorial. And yeah, you can do that in your head. That's awesome. Okay. See how those are kind of complicated? They're not that bad. You can do those. All right. Let's talk about Minnesota politics for just a minute. How many senators do we have? Do you guys know this? 2. It's an easy question because every single state gets 2 senators. How about the other kind? The House of Representatives. Now, how many we have? I've heard 6, 8, and 10 from various people. So honestly, is there anybody who is confident? 0 people are confident about this. I'm going to look at it. Okay, we have looked it up and it is 8. So if there's 8 reps and 2 senators, do you get every now and then that they get together and they talk? It's true. It's not very common. The senators probably talk a lot. There's only 2 of them. And I'm sure that the reps talk amongst each other. But they get together with the whole group and they talk. So let's say that they serve lunch to the whole group. And unfortunately, there was some bad shrimp. And 2 of them got sick. What's the probability that 1 rep got sick and 1 senator got sick? It sounds super complicated, but I've told you how to set it up. All 10 of them get together. 2 people got sick. What's the probability? That it was 1 of each. Hover over you. Find the notes. We'll be back to the notes in a minute, but I need to show you the hardest kind first, and then I think our notes will seem easy. All right. If you knew that there was 10 here and 2 people got sick, raise your hand if you had 10C2 on the bottom. Okay, good. Then there's only 2 categories, reps and senators. I'll call these the reps, and these the senators. And out of the reps, there's 8 of them. And what I wanted was the scenario where we got 1 that got sick. And then out of these 2 senators, 1 got sick. And if you check this, you'll make sure you did it right. Those 2 add up to that. And those 2 add up to that. Does that make sense to you? All right. Now, some of this you don't even need a calculator for. Like I can do that in my head. It's 8. I can do that in my head. It's 2. So the top is just 16. 10C2, not so quick yet. So take a second, finish this off, and you know that it's 8 times 2 is 16 on the top. Over 10C2, figure out the final answer as a decimal and compare it with the kid next to you. Take a minute. Actually do it.
Yeah, so I got decided 3 possible places that are supposed to be 2. Literally 2. Yes, but I got it. No.
0.35 repeating. So I'm going to call that about 36%. Or if I go to 3 decimal places like we would have to on our test, it'd be 3, 5, 5, 5, 5, and then you'd go, those are my 3 decimals. Do I round it up? Yes. 0.356. Who had 0.35-ish? Okay, good. All right. Good. Now, the rest of them are going to seem easy. Do you get that this CC over C is giving you a probability? Because in probabilities, you always divide by something. But if I had just said, how many different ways could something happen? I would just do the top of it. Almost all your questions for today are just, how many ways could this happen? I'll give you another one. How many different ways out of this classroom, who in here is wearing some sort of slides? He's got slides on. They're kind of like flip-flops or, like you slip your feet into them. How many of you are wearing those today? Raise your hand if you are. So you got 1, 2, 3, 4. 4 people with slides in here, all right? So start setting up the question. There's 33 of you total. If I were to pick out 2 people, what's the probability I'll get 1 with slides and 1 with regular shoes? There are 4 people in here who have slides on. As soon as I said probability, you should have known it would be CC over C. You got your slides and your not slides. 4 people with slides that just have to do math for a second, and you know how many people do not have slides. And I wanted the probability that I'd have, when I grab 2 random kids, I grabbed 2 random kids, that has to be a 2, that I get 1 of each. And I think this is 29, right? Okay. And I can do this in my head, it's 4. This in my head, it's 24. 4 times 24 over whatever 33C2 is. Okay. Now, how would I make this a ways question? I get rid of this bottom. Then it's not a probability anymore, it's how many ways. So, let's think about this. What is this question actually asking? How many ways can I choose out how many people? 2 people. How many ways can I pick out 2 people out of the classroom where 1 has slides and 1 does not? All right, I'm going to ask you the same kind of question, except slightly different. How many ways, same group of kids, there's 33 of you, 4 kids have slides. How many different ways can I pick out 2 people out of this class that both have shoes? It's almost like you'd set up a CC over C, except you don't need the bottom. So, you got your slides, you got your not slides. I'm going to say the question one more time. You know, I think by now that there's 4 kids with slides in here. A total of 33 people. How many different ways could I pick out groups of 2 of you and have it be 2 people with shoes on? I got slides and shoes, or not slides. And there's 29 people with, no wait, that's 29 people with shoes, 4 with slides. And then, I didn't say anything about the people with slides, so how many people did I want to get? 0. And then 2, there we go. I know some of you are thinking, couldn't you just done 29C2? Yeah. But you could also do this, and you get the same answer. And it works better because it helps you see, oh, I got the slides people included. It's just that I wanted literally to choose 0 of them. Okay. All right. There's people that like mayo on their sandwiches and people that don't. Curious, how many of you would say, yeah, put on some mayo? Raise your hand if you're the mayo person. I'm a mayo person. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 mayo people. Still 33 in the classroom. 14 mayo lovers. My question is, if I chose a random 3 of you, what's the probability I'd get 2 people that like mayo? If I choose 3, what's the probability that I get 2 mayo lovers? And I should even clarify, only 2. I don't want to get at least 2. That would be harder, and we're not going to do that. Only 2 of the 3 people chosen, like, man. Can you set up the CC over C? I now know that you all would be able to type it in on the calculator, but don't have to. Just can you set it up right? Please compare your CC over C with the kid next to you.
I got 14C2 times 19C over 33C2. You just type it in. First of all, needs to be answered to that. Because there's 19, 15%.
Wait, so for the I got like
I got 31.6%.
No, it's different.
Out of the not mayo persons, I'm just curious, how many of you like detest it? It's like, oh, so gross. All right, it's like 5 of you. It's kind of interesting that there's some foods out there that people are like, yes, give me more, and other people are like, ah, it's so disgusting. Who would choose pickles on your hamburger? Raise your hand if you're a pickles on the hamburger person. Oh, quite a few. That's more than half. All right. All right, so I think you've got the idea, and I think these slides are now going to go really fast. Do you get that permutations means that there's some kind of order involved? Okay, next slide. What if we have these marbles? Is this a probability question? No. So it's like a CC over C, except you don't have to divide by anything. Okay, well, then let's just set it up, the CC part. Is there only two groups? No, there's actually three. Three kinds of marbles. Green, orange, and blue. Now, if I set it up as CCC, then I got to tell you how many of each kind I get. Do you get? I don't know how many of each kind I get. So then I just actually want to do the bottom of the CC over C. It's just, I'm choosing 6 out of, in case you haven't added them up yet, it's 12 marbles total, and I'm choosing 6. That's it. It's like the bottom of the CC over C. Now, if they had told me how many of each kind, like I want you to get 2 orange ones and 4 blue ones, well, then you could have done the top part. Well, like this one, 4 green and 2 blue. Well, it's actually C, C, and C. You don't have to do the one where you're going to choose 0 of them, but you can. This is going to be our green. These are going to be our blue. And there's one more kind, orange. OJ is the classic abbreviation for orange. Classic mistake right here that gets people stumped. They're like, well, it says 4 green, so I'm going to put a 4 in front of the green. No, that's where the total number of green marbles goes. There's 5, and I'm choosing out 4 of the 5. Blue, there is a total of 4 of them, and I'm choosing 2 of them. And what does that mean for the OJs? Well, there's 3 of them, and I'm choosing how many? 0. If this bothers you, it's going to change the answer. It's not, because it just comes out to 1. So 5C4 times 4C2. Next slide. A bag of cookies contains 6 chocolate chips, 5 peanut butter, and 1 oatmeal. Get used to it. You're always going to end up having to add them all up. And it adds up to 12. So there are 12, and I am choosing 2. It's as simple as 12C2. Now, this is like top of the CC over C thing. This time they're giving me more specifics. 1 chocolate chip and 1 peanut butter. Then I got to know how many chocolate chip there were and how many PB there were, peanut butters. So then I'm going to look that up. Chocolate chip, there's 6 of them, and I'm going to choose 1. And the peanut butters, there was 5 of them, and I'm going to choose 1. Now, could I have done that in my head? You actually could have, because it's really 6C1, which is 6, 5C1, which is 5. You always multiply your choices. 6 times 5 is 30. The answer is 30. But you got to learn how to set these up. For this question, hardest of them all, CC over C. It's not incredibly hard now. We already did the top. We already did the bottom. You just got to put them all together. Savage, what's the top? Exactly. So it's 6C1 and 5C1 over, I think it's 12C2, isn't it? The other thing we figured out. And again, I trust you. I showed you how to enter that in the calculator. I'm sure you could. Just don't forget that this is times. This one times that one. And don't do everything on the calculator. Some of these are easy to do in your head. So that 6 times 5 is 30. 30 over 5C2 or 12C2. And I think we're good. Now, tonight's homework has problems just like that. And there's quite a few of them. I'm going to just skip the one that's about cards because I have a rule. If I'm ever going to assign you card questions, I have to give you a diagram that shows what all the cards are, because some people get it. Because you play cards a lot, other people have no clue. So we're skipping the card question, which I believe is the last one. Can anybody verify that? All right, so on the fourth question, just skip that last problem. Do the rest of them, set it up with C's. Actually, go ahead and multiply them out, of course. Don't just leave your answer as like 5C2. Do the math and figure out the answers. You can do it either way now. If you want to do it with the formula, 5 factorial over 5 minus 2 is 3 factorial with an extra 2 factorial. Cool. You need to still know that. Even though you'll have a calculator. That formula will come in. Because, what if we said, I'm choosing A of you? And you don't know how many I chose. Well, you gotta be able to use the formula to get the answer if we use a variable. 5 choose n. Then it'd be 5 factorial over 5 minus n factorial with an extra n factorial. I've seen ACT questions that are structured that way too, where you couldn't have done it with the calculator because they stuck a variable in it. So keep remembering the formula for it, but I get that you're going to use the calculator a lot more now that I showed you how to do it that way. All right, and that's all I got for you for today.